Hey, pre-calc. We're here back again to do some more with trigonometry in the unit circle. This is the T5 notes, so right after T4. So in T4, you guys learned about the unit circle and try to memorize what the degrees look like and all the degrees and in radians. And here we're going to use that knowledge that we learned in order to figure out the angle if we're given certain things, like you can find like the sine of an angle or something like that. So uh, with this, we look at these six trig functions, these six trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. And they all use the opposite, adjacent, and hypotenuse sides of the triangle that these angles create in some sort of way, and they're all a little bit different. Just remember that the sine and cosecant, those are reciprocals of each other. Cosine and secant are reciprocals of each other, and tangent and cotangent are reciprocals of each other. While sine, cosine, secant, and cosecant all use the hypotenuse in some way, the tangent and cotangent just use the opposite and the adjacent. So let's say we're given some angle. This angle is 2 pi over 3. And this is in radians. And our goal is to find all 6 of these trig functions of this angle. Well, what you should do is you're going to draw a unit circle, not a unit circle, just a regular circle, actually, just like that. And for all of these, we're going to just draw a line like that. That'll show the beginning angle. And we show how far 2 pi over 3 is. So we know it's an over 3 angle, and we know that it's not pi over 3, it's 2 pi over 3, so it's the second one. So it's in this area. This is the angle that it creates. That angle has a larger y than it does a x. So we know we're going to use somehow 1/2 and the square root of 3 over 2 in some sort of way. Because we know that square root of 3 over 2 is bigger than 1/2, the y is bigger here. So we're going to want to use the square root of 3 over 2 for the y and the 1/2 for the x, just like that. However, because if we were to break this down into like a 4-section area, like a coordinate plane, we would know that's in quadrant 2, which means which of those have to be negative. If you said the x, you would be correct. So the x value has to be negative. So we have negative 1/2 and square root of 3 over 2. And I can rewrite that just right here, negative 1/2, the square root of 3 over 2. That is what these lines mean. So the sine of any angle is just the y value of these points. So the y value here is the square root of 3 over 2. So that's what the sine theta is, square root of 3 over 2. Cosine is just the x, so it's negative 1/2. Again, I just got those from these positions right here. The next thing you have to do is try to figure out the tangent. And if we remember, the tangent is sine over cosine. So if we have the sine, which is 3/2, and you're going to multiply that by the reciprocal of the cosine, which is negative 2 over 1, we would get negative 2 square roots of 3 over 2, which reduces to just negative square root of 3 over 1. So this is the negative square root of 3 over 1. And remember, you can have the negative on the outside of the radical, like a negative square root of 3, but you cannot have it inside the radical. That would make it an imaginary number, so you don't want that. Okay, so next thing we do is the cosecant. And what's kind of nice about these things is you can just do the reciprocals of the sine, cosine, and tangent. So the cosecant is just the reciprocal of that, which is 2 over the square root of 3. All I did was just flip these things to get the cosecant. However, you can have a radical inside or on the denominator. So what you have to do is just multiply by the root of 3 over the root of 3, which is just multiplying by 1, because the root of 3 over root of 3 is just 1. Multiply straight across. 2 times the square root of 3 is 2 square roots of 3. And square root of 3 times square root of 3 is just 3. So the cosecant of this angle is 2 square roots of 3 over 3. And then the cosecant is the reciprocal. This one's a lot easier because you don't have to do any of that. It's just negative 2 over 1. Again, you're flipping the cosine. And then last but not least, you're doing this with tangent. So you have square root of, sorry, my bad, let me erase that real quick. I'm going to erase this as well just to give myself a little bit more room. You can go back to the other part of the video to see that if you still need it. So the cotangent is just the reciprocal of this, so 1 over negative square root of 3. And again, you can't have a radical in the denominator, so you're just going to multiply by the square root of 3 over the square root of 3, and then you get square root of 3 over 3, and just make sure 1 is negative. There you go. And so we have the cosecant, secant, and cotangent now. The problem is done. We figured out all of our angles. Next one. Again, we're just going to draw a circle. You don't have to do this. I think this just makes it easier for me. We know we always start like that. And then this is pi over 2 is normally like this. That's pi over 2. But because it's negative pi over 2, it goes in the opposite direction. It goes clockwise, not counterclockwise. So it looks like that. That we care about, which is a 90-degree angle. All right, so a couple things we know. We know 90-degree angles. We have zeros and ones are what they work with. So this angle goes straight down, so it has a y value, but it doesn't have an x value because it doesn't go left or right at all. So it's 0, negative 1. Because remember, when you go downward, it's negative. So 0, negative 1. All right, that's your point. That's what you have to care about. Remember, sine is just the idea that we have whatever our y value is. So that is negative 1. While cosine is whatever x value is, or 0. Tangent, a little weird, because it's sine over cosine. So you would think negative 1 divided by 0. But when you try to divide something by 0 in your calculator, it gives you an error. This is an undefined. There is no tangent. So this is undefined. And then we have cosecant, which is the reciprocal of this negative 1. So all we got to do is go 1 over negative 1, and that's negative 1. So the cosecant is also negative 1. The secant, if we flip that, gives you 1 over 0, which unfortunately is also undefined. But if we flip the tangent, negative 1 over 0, it's 0 over negative 1, which ends up being 0. Again, to find cosecant, secant, and cotangent, we're just flipping. And if you remember from some basic math, that all numbers basically have a 1 in the denominator if no other thing is in the denominator. And that's why we can flip them and put the 1 on the top. Let's go to the next one. 30 degrees. So I'm going to draw another circle. 30 degrees. Again, we're going to start here. 30 degrees goes about in this direction from your memorization. And that means we're going to use 1/2 and the square root of 3 over 2 in some sort of way. But in this case, the x is farther away because it's a more, it's closer to the x axis than the y axis. So this is a square root of 3 over 2 1/2 problem. That is the point from the unit circle at 30 degrees. The sine of that is the y value, which is 1/2. The cosine is the x value, the negative, or not the negative, the square root of 3 over 2. And the tangent is sine over cosine, which would be sine 1/2 times the reciprocal of square root of 3 over 2, so 2 square roots of 3. These would cancel out, giving you 1 over the square root of 3. However, we do have to multiply both sides, or the top and the bottom, by the square root of 3 over the square root of 3, because you can't have a radical in the denominator. And we get the square root of 3 over 3, which would be your tangent. Square root of 3 over 3. The cosecant is just the reciprocal of the sine, so that's 2 over 1. Secant is the reciprocal of the cosine, so 2 over the root of 3. But remember, you can't have a reciprocal in that, so you got to do square root of 3 times square root of 3 to get 2 square roots of 3 over 3 as the final answer. Again, we're just doing that because we can't have a radical in the denominator, and it's basically multiplying by 1, which doesn't change the value. And the cotangent, to figure the last one out, is the reciprocal of this thing right here for the tangent. So I'm going to erase again just to give myself a little bit more room and doesn't get all clogged. So the reciprocal of square root of 3 over 3 is 3 over the root of 3, but again, going to do multiply by the root of 3 over the root of 3. and we get 3 roots 3 over 3. And what's nice is these just cancel out, just like that, and you get the square root of 3 as the final answer. And you can see that because the root of 3 times the root of 3 is 3, and so the numerator and denominator 1 will cancel out. Last one on the first page, let's go to number 4. This is the angle of 225. So we're going to draw the circle. 225 is like this. Maybe I can draw a little bit better. Because it's going to be not a square root of 3 over 2 or 1/2. This one's going to be somehow a root of 2 over 2 and a root of 2 over 2. But you have to figure out which ones are negative. And because this is in quadrant number 3, both are negative. If you remember our quadrant rules, that if it's in the bottom left-hand corner, they're both negative. The sine and the cosine are actually the same thing here, because they're both negative square root of 2 over 2. The tangent is the reciprocal, or sorry, the reciprocal, the multiplication, division of sine and cosine. So the sine is the square root, negative square root of 2 over 2, and you have to multiply by the reciprocal here, which is negative 2 over the square root of 2. But this is kind of nice because these cancel out, and these cancel out, and the negatives cancel out, which just gives you 1, which is very nice. Then we do the cosecant, secant, and cotangent, which are just the reciprocals. For the cosecant, we have 2 over negative root 2, multiply both sides, both the top and the bottom, by the square root of 2, and we get 2 root 2 over negative 2, and we can cross those out, leaving us with just negative root 2. You can use negative root 2 over 1 if you want. Those are the same thing. Then we have the secant, which is the reciprocal of the cosine. So we have negative, which is going to be the exact same thing, because we know the sine and cosine are the exact same. So we have negative square root 2. I didn't do any work for that because the exact same work you see for cosecant. And then cotangent is just reciprocal of 1, which is just 1. And that's it. That's your first part, where we have each of the thetas. We're given some sort of angle, either that be a degree or a radian, and your goal is to sketch it, figure out what these points would be, and then find the sine, cosine, tangent, cosecant, secant, and cotangent from those points. Our next page asks, without a calculator, sketch the angle and evaluate each of the following and rationalize the denominators. So we have the cosine of 5 pi over 6. So we know it's a pi over 6. So we know it's closer to the x-axis. So we have this here. We know it's not just regular pi over 6, and it's not a full pi yet. So it's going to be in this direction over here. This is quadrant number 2. So we know the cosine here is going to be either the square root of 3 over 2 or 1/2. And then maybe negative, we don't know yet. And that's because it's a pi over 6. So let's think. Cosine is the x, not the y. So we know this is closer to the x-axis if it goes farther in the x than it does in the y. So we know that's going to be the root of 3 over 2 in some sort of way. But we also know not only is it the root of 3 over 2, but it's negative because it's in quadrant 2 and it's an x, because cosine, when you do that, you can think of x, the x value of the line. And when you have sine, you think of the y. For cosine, thinking of your x, we know that's 3 pi over 2, and we know it's negative because it's in quadrant 2, so we know negative root 3 over 2. If this was the sine, it would just be 1/2. And then secant, you know, the secant here. When I see secant, what I usually like to do is just go straight to, after I draw it, just switch it to cosine and just flip it. I think it makes it a little easier for me. So let's look. 4 pi over 3 is a pi over 3, but it's more than pi, so it's going to be like here, right here, and this is quadrant number 3, so we know it's going to be negative in some sort of way. So it's this angle that's formed right here, and it's formed here. So this is all for memorization, just doing the Q3. And I know this is a pi over 3, so I know that it's going to be a square root of 3 over 2 and a 1/2. And because I know it's closer to the y-axis than it is the x-axis, the y is going to be bigger. So you have 1/2 and the square root of 3 over 2. Let me rewrite that. I know that's kind of ugly. I'll scroll in to make it a little easier to see. So we have the y being bigger, so we have 1/2 and then the root of 3 over 2. We know they're both negative because it's in quadrant 3. We know the cosine is the negative 1/2. So we know the cosine here of the theta of the angle is equal to negative 1/2, because that's this. And we know cosine and secant are reciprocals of one another. So for to find the secant, if the cosecant is negative 1/2, all you gotta do is flip it. So the secant of 4 pi over 3, which is the angle that we care about, will just be negative 2 over 1, or just negative 2. Up to you, however you want to write that. So for this problem, because it's not just cosine, tangent, or sine, what I first do is just find the cosine and then just flip it, because I know secant and cosine are reciprocals of each other. Same thing here, we have the cosecant, and cosecant is the idea that we're going to look at sine of an angle. To first do that, though, we're going to draw a circle, start here, and this is 3 pi. So one full rotation around is 2 pi. So if we just cut out 2 of this pi, we're left with just pi by itself, because we just subtracted 2 pi from there. So we're left with just pi, and we know pi is a 180-degree angle, like this. From there, you have to know that it's going all the way to the x, that's negative, so negative 1, and it doesn't move y at all, that's 0. So a straight line like that is negative 1, 0. So the sine of that is the y value, so that's 0 right here, because that's the y value. But we're looking for the cosecant, which is the reciprocal of 0, and the reciprocal of 0 is 1 over 0, which is undefined. So this answer is undefined. Now we're looking at the tangent of negative 45 degrees. So again, all we're going to do is draw our circle. And this is negative 45, so it goes right here. This is the angle that's formed. Because it's a 45-degree family, we know it's going to be square root of 2 over 2, comma, square root of 2 over 2, and we just have to figure out which ones are negative. It's the x one, because it's in quadrant number 4. The x value is positive, and the y value is negative. And because we know this is a tangent, we want to do sine over cosine. So the sine is negative 2 root 2, and the sine is square root of 2 over 2, but we're going to do the reciprocal of that, so 2 square roots of 2. These cancel out, but you're left with still 1 negative, so you're left with negative 1 as the tangent. And again, here's a cotangent one. So my big goal is to find the tangent and just do the reciprocal of that. Another way you could do that is just instead of doing sine over cosine, you could do cosine over sine. Either way, it means the same exact thing. So we're going to draw a circle, draw a line, and negative 120 is somewhere in this area. Negative 120. We know it's going to be 1/2 and square root of 3 over 2, and because it's in the quadrant 3, we know they're both going to be negative. So in that case, I have to make sure I figure out, is it closer to the y-axis or closer to the x-axis? And this is closer to the y-axis, so that's going to be bigger in the y. So we have the root of 3 over 2 here, negative, and the 1/2 here, negative. Now, cotangent is, regular tangent is sine over cosine, but cotangent is the opposite of that, so cosine over sine. So I know the cosine is 1/2, or negative 1/2, and I want to divide that by the negative square root of 3 over 2, or the reciprocal, multiply the reciprocal, so negative 2 over root 3. I can cross these out, but I still have a negative up here. So I have negative 1 over the root of 3, because negative 1 times nothing, or times 1 is negative 1, and 1 times square root of 3 is 3, square root of 3. And then all you gotta do then is multiply here. That's right, both these negatives cancel out, so this is gonna be positive, my bad. This is going to be positive, because negative and negative cancel out. So we have this, and just multiply it by the root of 3 over the root of 3, because I don't want reciprocals, or no, sorry, I don't want radicals. The root of 3 over 3 as the final answer. The root of 3 over 3. And the last one of this section, the cosecant of 315 degrees. Again, I'm just going to draw this poor circle. Please let me redraw it. Don't make fun of me. All right, you got here, and then it's going to be in this section right here. This is a 45-degree family, so you know you're going to use square root of 2 over 2 and the square root of 2 over 2. And we have to figure out which one's negative because it's in quadrant 4. Quadrant 4, the x is positive and the y is negative. So we have a negative up here. Okay, so we're looking for the cosecant. So that's the sine as the reciprocal. So if we're looking for the sine here, the sine is equal to negative root 2 over 2. And to do the reciprocal of that, so we have the cosecant of 315 would be the negative 2 over the root of 2, but I can't leave it like that because it's a radical. So I should multiply it by the root of 2 over the root of 2. And I'll get negative root 2, sorry, negative 2 times the square root of 2 over 2. These cancel out, leaving you with a final answer of negative square root of 2. All right, sweet. 2 more sections. This one's not too bad. So we're going to note the following pattern for positive and negative signs. We've kind of already talked about this a little bit. What are the quadrant signs for each of the following? If you remember, sine is like the y value, cosine is like the x value, and then tangent is a combination of them. We can kind of figure this out. So cosine of pi over 17, pi over 17 is like right here, something like that. If that's the case, we're just sketching it. And I know pi over 17 is like that because it's a very small number. It's less than pi over 2. And because I know that, I can say, well, it's in section 1, so the cosine is going to be positive. So because it's in quadrant 1, it's going to be positive. That's all we're saying. And we get 12, negative 2 pi over 5. Again, that one is going to be in this section over here somewhere. And this is quadrant 4. So the sine, again, the sine is the y value, so this one is going to be negative. Then we have the secant of negative 6 pi over 7. So if we look at negative 6 pi over 7, we would get somewhere in this section right here. That is going to be quadrant number 3. And we're looking for the secant, but if you remember, secant is just the reciprocal of the cosine, and because we have a cosine that's negative in this section, we also have a secant that is negative in this section. Oh, cool, we have a tangent one now of 42 degrees. So we know 42 degrees is somewhere up in this section, and the tangent there is positive sine over positive cosine, and in that case, quadrant 1, everything's always positive in quadrant 1. And then in cotangent of 93 degrees, so that's slightly over quadrant 1 going into quadrant 2, and we're looking for cotangent. So we know the tangent is negative in that section because we know sine over cosine, positive divided by a negative is a negative, so we know the tangent is negative. And if the tangent is negative, so is the cotangent. Quadrant number 2 is negative. And the last one is the cosecant of negative 324 degrees. So not 324 degrees, but negative. So that actually goes all the way around, ending up in this section somewhere. And in that section, that's quadrant 1, and everything in quadrant 1 is always positive, every single time. Sine, cosine, tangent, anything. Cosecant. All right, this is the last section. Evaluating trig functions with circles of any radius. So far, all of our radiuses have been 1, which has made our life a little bit easier because the hypotenuse is every single time 1. It might not always be the case. So for the unit circle it is, because it is just 1. But in this case, if we were to make this triangle, I'll show you, we know this is a point, negative 4, 8. So if you have negative 4 right here, and we have 8 up here, this triangle is the triangle that's being formed. That orange triangle is being formed. So if I were to redraw that triangle just to make it a little bit bigger and easier to see, I know this side is negative 4 and this side is 8, which we can find that hypotenuse by using the Pythagorean theorem. 8 squared is 36, 4 squared is 16. That gives you 36 plus 16, which gives you 50, sorry, 50, I'm wrong. Oh, no wonder I messed up. I said 36. Don't listen to me about that one. 8 times 8 is 64. 64 plus 16 is 80. So we know c squared is equal to 80, or c is equal to the square root of 80. And if you reduce that, that'd be 4 roots of 5. Okay. So what does that even mean? Well, now that I have this being 4 root 5, like that, we don't really care about this negative 4 right now, real quick. Actually, I'll keep it. So we have negative 4. So we have 8, negative 4, and 4 roots 5. And our goal is to figure out what the sine, cosine, and tangent, cosecant, secant, and cotangent are. Remember, sine is always opposite, because we're always working at this angle right here. This is the angle we care about. Is always opposite over hypotenuse. So the opposite of that is 8 over 4 roots of 5. That's the hypotenuse. These can cancel out 8 and 4, leaving you with 2 over root of 5. And then I can multiply the top and bottom by the root of 5, and that gives you eventually 2 root 5 over 5. So 2 square roots of 5 over 5. You can't see that. The cosine, again, is the adjacent over the hypotenuse. So the adjacent is negative 4, while the hypotenuse is 4 roots 5. These can cancel out, leaving you with just negative 1 over the root of 5. And then you can multiply them by square root of 5 over square root of 5. And that will give you negative square root of 5 over 5. And the tangent then is when we do sine over cosine. So 2 root 5 over 5 times the reciprocal of that, which is going to be 5 over negative square root 5. These cancel out, leaving you with just negative 2. I like the cancellation, makes things a lot easier. Next thing we're going to do is we're going to focus on the reciprocals of these for cosecant, secant, and cotangent. Cosecant, again, just the reciprocal, 5 over 2 root 5, multiplied by root 5 over root 5, and we get these to cancel out, and we get 5 over 2 square roots 5. But unfortunately, we can't leave it like that. You're going to multiply them both by the square root of 5, so we get 5 root 5 over 10, which does reduce to give us square root of 5 over 2. And I know that's a gross process, but that's what it is. Next is the secant. This one's not as hard. We do the reciprocal. We get 5 over the square root of -5. And you just multiply them both by square root of 5 over square root of 5 to get 5 root 5 over -5. These cancel out, leaving just negative square root 5. And the last one is the cotangent. This one's the easiest one. Reciprocal of -2 is just -1/2. Right, last problem, number 18. This is -2 over 5 and the square root of 21 over 5. Here, again, we're going to draw the circle. And then I can know that this part of the x is -2 over 5, and the y here is, let's see here, is 21 over 5. Let's see. Draw that a little bit. Here, here, and we know color. Right here is like -2 over 5, and right here is like the square root of 21 over 5. When you were to draw that, this is the angle that's created. And again, I'm going to redraw this triangle to make it a little easier to see. So this side is -2/5, and this side is square root of 21 over 5. And your goal is to figure out the hypotenuse. And if you do them squared, you get 21 over 25 plus 4 over 25. And that gives you nicely 25 over 25. So c squared is just equal to 1, so c is also equal to 1. This makes our life a whole lot easier if the hypotenuse is just 1. So I'm just going to give you the answers on this one, just because we've already done this part. We have square root of 21 over 5, -2 over 5, square root of 21 over -2, 5 root 21 over 21, secant is -5 over 2, and the cotangent is -2 square roots of 21 all over 21. These are the final answers, and you can look at that, take your time. So these are the video notes for Unit 5. Good luck on the test that's coming up. This is Unit Circle Trigonometry. I hope you have a fantastic day. Make sure you go back and look at any videos that you might need to still look at. All right. Peace out, guys. Hope you're having a good one.